Compressible flow tutorial number 7. A. Explain briefly the development of a conical Mach wave by a supersonic flow. B. In an Army airplane test flight, the meter device recorded on the ground giving an altitude of the plane is 6,000 meters. An average temperature is 5 degrees Celsius and the airplane speed is constant at 1800 kilometers per hour. What is the distance that the airplane has to travel from the meter device before the sound of the airplane is first heard? C. At a point in a supersonic airflow, the pressure and the temperature are 10 kilopascal and 60 degrees Celsius respectively. If the stagnation temperature at this point is 57 degrees Celsius, find the Mach number and the stagnation pressure at this point. Assume it is isentropic flow. Students also can use a table provided to solve this problem. So it is given that air specific ratio gamma or K is equal 1.4 and gas constant R is equal 287 joule per kilogram Kelvin. To answer question A for Mach wave and Mach cone here, so I hope you could draw basically these four diagrams. For example, if we have a sound source here, so and the sound source, the object is not moving, we could draw the sound wave is like this. And then if the object moving at slow speed, mean in subsonic speed, so we could see that the sound wave denser at the right side. And then if the object move at sonic speed, means at Mach number 1 here, so we could say that it is densest sound wave here, and we could say that the shock wave will occur at straight line perpendicular to the motion here. And then if object moving at supersonic speed, so the Mach cone is occur here, and the sound of wave will can be drawn like this. So please read about this from your textbook, and I hope you could explain about the formation of shock wave clearly. This is just for the guideline to answer that question. For question B, we know that the velocity needs to be calculated in SI unit, mean in meter per second. So we need to change 1,800 kilometer per hour into meter per second. I hope you could do this. And the answer is, it is around 500 meter per second. Then we need to calculate the speed of sound by using this equation. Set KRT, K is 1.4, R is 287, and T is 273 plus 5 degrees Celsius. So it's, please bear in mind that the temperature here need to be calculated in Kelvin. So we get that the speed of sound is around 334.22 meter per second. We could calculate the Mach number by using this equation, and then we get it is around 1.496 Mach number. From the question, we know that the jet will fly like this and will create an angle here, Mach angle here. So we could say that alpha can be calculated by reverse sine 1 over Mach, and we use the value of Mach number here. We get alpha here is 41.95 degree. And by using the trigonometry, we could calculate that the x here, the distance here, is around 6,675 meters. This is question for C. At a point in supersonic airflow, the pressure and temperature are 10 kilopascal and minus 60 degrees Celsius respectively. If the stagnation temperature at this point is 57 degrees Celsius, find the Mach number and the stagnation pressure at this point. Assume it is isentropic flow. Student can solve this problem by using the table provided. So what you need to understand here is, first you need to imagine we have a convergent divergent section like this, and then the flow move from left to right here. It's first the condition is subsonic. When it's go to the throat here, it's being compressed, and its flow in supersonic in point number 2 here. So the question asks you, in normal condition means if the gas continuously flow here, the pressure at point 2 is 10 kilopascal, the temperature is 213 Kelvin, and the question asks you to calculate what is its Mach number at point 2 at the supersonic airflow. Then, if this flow is stopped immediately and become a stagnation condition, the temperature increase into 330 Kelvin. So what is the stagnation pressure at that time? So this is the question for C. So what we need to do is we list all the parameters from the question. So we have pressure 10 kilopascal, we have temperature before the stagnation is 213 Kelvin, and temperature at stagnation point is 330 Kelvin. So the question is, what is Mach number before it's become stagnation point, and what is the pressure at stagnation point? So to solve this problem, normally if we have two readings of temperature here, it is worth for us to use this equation, because the isentropic flow for temperature, it has both before and after temperatures reading. So we have both temperatures reading here. So mean this question is worth to be used to solve this problem. Okay, let's say we use the isentropic flow for temperature. So this is the equation. I hope you remember this one. And then we substitute T2 as T0, means temperature at stagnation condition. So it is 330 Kelvin. T1 will become temperature before the stagnation point. So it is 213 Kelvin. We use K as 1.4 because our medium now is an air. M2, Mach number at stagnation point, so it is equal to 0. And M1 is Mach number that before the stagnation point, means Mach number that we want to calculate. And then we do the calculation, we could get that M, the Mach number, before the stagnation occur is 1.657. And then to get the value of stagnation pressure here, we use the isentropic flow for pressure. We have P2 over P1, and these terms, we substitute all the value. Similarly with the previous solution, so we substitute P2 as P0, pressure at stagnation condition, P1 as 10 kilopascal, M2 is equal to 0 because it is Mach number at stagnation condition, and M1 is equal to 1.557. So this value is calculated previously. We solve this equation, we get that pressure at stagnation point, we also could write as P0 here, is equal to 46.27 kilopascal. Student also could use table to solve this problem. So how to use table? So I will show you here. So let's say we know from the question, we know that temperature before the stagnation is 213 Kelvin, and temperature at stagnation point is 330 Kelvin. So the ratio of T over T0 is 213 over 330. So we get 0.6455. So what we need to do is we go to our isentropic table. So we found that This value 0.6455 is actually between 0.6502 and 0.6447. So means that we need to take this value in our calculation. Means that the Mach number must be between 1.64 and 1.66. So what we will do the interpolation of this to get the value of M and the value of P naught over P. Be careful here because sometimes in isentropic flow table, sometimes it will give you P naught over P, T naught over T, and A over A star column. So A over A star is likely a common term, but sometimes you have T over T naught column or T naught over T column. So please be careful and look carefully what type of table they provide to you. So in this table that I show you, and you could also download this table from my website. So I give you P over P naught and T over T naught. So we make a table like this. So we have a Mach number, we have T over T naught, and we have P over P naught here. So we have Mach number 1.64 and 1.66. So the ratio of this one is actually in between 1.64 and 1.66. So we write this as 0.6455. So and then we need to calculate what is the value of A, mean the Mach number that create T over T naught 0.6455, and what is the ratio of pressure that give this value to. So I think you already know how to solve this one. You may do the interpolation by having this equation. I simplified this one. I thought you already know how to calculate this, and then we could say that the value of A is equal to Mach number, and it is equal Mach 1.657. And then we could also calculate the value of B, and we could do the interpolation like this, and we could say that B is equal P over P naught, and it is equal 0.2161. Then, because we already know the value of P here from the question, we could rearrange this equation, and we could calculate the value of P naught here by having 10 kilopascal over 0.21606. So it is better for you to have 0.2161 here, and it is equal 46.27 kilopascal. We find that these answers both are totally the same answer compared with the previous solution. So means that you have two choices, whether you want to calculate by using the equation or you want to use table to solve this problem.